Okay, congruence and triangles. Here we go. Just 18 questions. All right. Complete each congruence statement by naming the corresponding angle or side. Okay, so if, clearly FD is congruent to side FD is congruent to side IK. Notice that I put it in order, not alphabetical order, but paying attention to the angles involved. Here, angle A, having the two small arcs, is congruent to angle M. And angle U, in this case, well, here it's not all labeled, all pretty. Instead, you have to follow the letters. Although TUV, GFE, it's pretty obvious that angle U is congruent to angle F. WVU is congruent to GHI. So what corresponds to angle W? Well, that would be angle G. But we can make it explicit. W, V, U is congruent to triangle G, H, I. And so angle W is congruent to angle G. Z, X, Y, triangle Z, X, Y is congruent to triangle Z, X, C. And so angle Y is congruent to angle C. And I just realized I've been doing all of this in red. I don't want to do that. Oh well. Okay, so angle W is congruent to angle G. And angle Y was congruent to angle C. And here, triangle DEF is congruent to triangle DSR. Therefore, angle F is congruent to angle R. Now write a statement that indicates that the triangles in each pair are congruent. Okay, so triangle triangle JKI is congruent to triangle TRS. Triangle BCD is congruent to triangle GHI. Triangle PQR is congruent to triangle QPD. Triangle SRI is congruent to triangle RST. Triangle VWX is congruent to triangle CDE. Triangle STU is congruent to triangle CDE. Mark the angles and sides of each pair of triangles to indicate that they are congruent. So it says or claims that triangle BDC is congruent to triangle MLK. So B, D, C, M, L, K. And now to indicate the sides. So I noticed that they kind of always do like one mark opposite the three little tiny arcs. So adhering to that convention, I suppose it would look like this. Like that. Triangle GFE is congruent to triangle LKM. So here's triangle G, F, E, and that's congruent to triangle L, K, M. And then following this, it would look like this. Now, triangle MKL is congruent to triangle STL. So here's MKL, and STL. And here's my indication of the sides. There. Triangle HIJ, HIJ is congruent to triangle JTS. So JTS there, like that. 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. And triangle CDB, CDB is congruent to triangle CDL, CDL. And we can indicate that like this. And finally, triangle JIK. Triangle JIK is congruent to triangle JCD. So JIK is congruent to triangle JCD. 1, 2, 3. 1, 1, 1, 2, 3, 1, 2, 1, 2. And now to check everything, make sure everything's right. Okay, that's in agreement. That's in agreement. That's all in agreement. Okay, that's in total agreement. PQR, QPD, SRI, RST, good. VWX, CDE, good. STU, CDE, good. Now let's see how they've marked them. Okay, so they followed my order there. That's all good. That's even better. That's right. Okay. Okay, so they differed a little bit there from MKL. Okay, that's fine. STL, right. Okay, we're in agreement about that. And then going from 2 to 3. Okay, so I understand the error now. Let me try again. Right, okay. Right, okay. So I understand the sort of convention now. So just to be sure about things, I'm going to try this again. That's good. No, that's wrong. Okay, it goes 1, 2, 3, and 1, 2, 3, and 1, 2, 3, 1, 2, 3, and check. Okay, this is accurate and correct. Good. It's the best thing. Some buzzing helicopter is outside. And it'll just circle around. Not sure why though. It's either searching for someone or it's searching for a landing spot, and I don't know. It doesn't matter. Now, state if the two triangles are congruent. They may be, they may not be. And if they are, state how you know. Okay, so this isn't territory I'm experienced with, so I must check every two. So I believe that these are congruent. And the reason why is the side angle side. Side angle side theorem. Side, angle, side, side, angle, side. Okay. I don't know what this is. Is this to indicate that these are equal angles? I believe so. If it is, I would suppose that side angle side, and no, actually. No. There's no theorem which states that these would be equal. And I must check. All right, so that's correct for these two. Okay. Side angle side. Side angle side. So yes, by the side angle side theorem. Side 1 angle side 2. Side 1 angle side 2, no. Check. Correct. Side 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 theorem. Three sides that are congruent, therefore the triangles are congruent. Side 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 theorem. And check. And that's correct. Side 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 theorem, so they are congruent. Side angle side theorem, so they are congruent. No, they're not congruent. Although they share a pair of sides and they share a pair of angles, they're not congruent. Side angle side, side angle side. So yes, they're congruent. Okay. State what additional information is required in order to know that the triangles are congruent for the reason given. Okay, so it says side angle side. We would need the magnitude, sorry, the length of segment JI and segment IE. As this is the side angle side theorem, we would need the measure of angle KLM and the measure of angle IHG. Those will be required. Check. All right, so here they're explicitly saying that it would be required to know that the length of side JI, or rather that side JI, whoops, is congruent to side IE. Likewise over here, KLM, angle KLM is congruent to angle IHG. Or they've put it as angle L is congruent to angle I, which is nice as well. Now for this side-side-side theorem, we would need to know that side dx is congruent to side yz. Over here, we would need to know that side RT is congruent to side XZ. And here, for the side angle side theorem to be employed, we would have to know that side WU is congruent to side XZ. We would have to know that side EG is congruent to side YW. No, go in order. This is very frustrating, this helicopter outside. Okay, so here EG it'll run out of fuel. They'll complete their mission eventually, but it's just very frustrating while it's happening. Okay, so side EG is congruent to side QG. That's what we'd have to know. For the no, wrong. See, I'm not concentrating due to a distraction, but anyhow, for the side angle side theorem, we would have to know that this angle here is congruent to this angle here. And I name this angle here GFE. And I name this angle here QFG. And for the side angle side theorem to work in this case, we know that these two angles are equal. That is, the angle DSB, angle DSB, and angle TSR are equal because they are vertically opposite, they're congruent. And so we would need to know that side ST is congruent to side SD. And now we must check. Okay, that's all valid and well. And that helicopter is still buzzing. All right, so side angle and angle side congruence. So once again, this is sort of, it is like, I do know this, but it's just I've never really been explicit and thorough and rigorous about it. So in that sense, it's unfamiliar. State if the two triangles are congruent, and if they are, state how you know. Yes, these are congruent, and I know this because of the angle-side-angle theorem. Yes, they are congruent, and I know this because of the angle-side-angle theorem. Now, these angles here are vertically opposite. So yes, they are congruent. These two triangles are congruent because of the angle-angle-side theorem, or better, more conventional, the side-angle-angle theorem. But in this particular case, they called it the angle-angle-side theorem. So we'll adhere to what the house rules are. No, I don't actually know if these are congruent. These are vertically opposite angles. And therefore, yes, because of the angle-angle-side theorem, no. So that's correct. Yes, because of the angle-angle theorem. Does that exist? No. All that means is that they are similar. Not congruent, similar. So an S, sort of like an S, like that, but reflected and rotated. Anyway. Okay, these two angles here, these vertically opposite angles here are equal. So angle-angle-side theorem, angle-angle-side theorem. So yes, by the angle-angle-side theorem, yes. Okay, good. These two triangles here, yes, because of the angle-side-angle theorem. And yes, because of the angle-angle-side theorem. That's strange. That should be angle-angle-side. Well, I guess that applies as well. State what additional information is required in order to know that the triangles are congruent for the reason given. Okay, if it's angle-side-angle, then I would have to know that angle DCQ is congruent to angle EDC. For the angle-side-angle theorem to apply, I would have to know that